What I'd like to take a look at next is what I call lazy OSPF config. Now, I'm going to shame anybody who does this. Lazy OSPF config means that your time is so valuable that you're unable to advertise each individual network on your router. Because your time is so valuable, you can only advertise it using this statement in OSPF. Network 0.0.0.0 with a mask of 255, 255, 255, 255. Now, that wildcard mask there of all 255s, that means everything, right? So this network statement effectively tells OSPF to advertise any network that is directly connected to the router. This is lazy. This is very, very lazy, and you should be shamed if you do this. Why should you be shamed? This specific lazy configuration can easily cause a network outage that, one, you will never expect to happen, and two, because you're never going to expect it to happen, you can create some very unusual behavior on your network that makes it very difficult to troubleshoot. So here, by being lazy in your configuration, we can easily cause some drama in our network and actually cause an outage. Now, I have personal experience with this precise situation causing a network outage at a hospital during the middle of the day. All right. And the person that created the problem had no idea that they shut down an entire nursing unit in the hospital because of one simple mistake. So here we go. Here's our entire network. I do have this set up in a lab, and I have the configs up in the exercise file section. What happens here? All the routers in this network are using the general network statement of 0000 with all 255s in area 0. Imagine that router B is our end users, all right? So connected to F01 of router B, we have end users out there that need to use the network. Then down on our layer 3 switch, let's just imagine that that's our data center. And in the data center, we have a bunch of servers that our users that are out at router B need to access. Well, what happens with this if my network administrator needs to do some testing in the data center? So they build up an interface, let's say this case, interface fast Ethernet 04, and they hook their PC up to it. And let's say that they do not look at the documentation for how the network is configured. They have no expectation that the route that they're adding here, the network they're adding to the layer 3 switch, will get advertised in OSPF. Because why would it? They're only setting it up for testing. They may not even realize what this network statement does, advertising anything that's directly connected. So here we have an administrator that didn't really do any due diligence to make sure network 10.0.2.0 wasn't already used on the network, without checking anything else and having OSPF automatically advertise any network that's connected to a router. What happened now is I have instantaneously broken the network. Our users over on router B now on F01 are 100% unable to communicate with devices in the data center connected to the layer 3 switch. Why is that? Well, on router B, we can get our messages to the layer 3 switch just fine. But once they get to the layer 3 switch, they may even get to our server just fine. But when the server replies, it's going to send the reply back to a destination of 10.0.2.10. It's going to hit the layer 3 switch. Layer 3 switch, if we remember from the previous conversation, it's going to trust a directly connected network over an OSPF learned route. So now my destination, 10.0.2.10, the layer 3 switch thinks that that network is directly connected. So it doesn't have an OSPF route on it. Therefore, we instantaneously black hole all of the traffic on router B into this test network we set up on our layer 3 switch. This event happened instantaneously. It happened without the network administrator's knowledge, and it broke the network in a way that was very difficult to troubleshoot, because this is not an issue that we would expect to have. We do not expect to have the same network on two different pieces of equipment in our network. Now, this could have all been prevented if we advertised each OSPF network individually. This problem would have never existed, right? The administrator on that layer 3 switch would have created network 10.0.2.0. It would have been just fine. It would not have gotten advertised. Now, the users on router B connecting to the data center would still have an issue. It just wouldn't get propagated out into the rest of the network. So we want to avoid propagating these issues that we can create here. Let's take a look. I do have all my routers pre-configured. Right now, let's connect to router C because router C is going to demonstrate the issue firsthand here. So we'll open up PuTTY and connect to router C. Show IP route. So right now, we should see that network 10.0.2.0 leaves out fast Ethernet 0.1, which is directly connected then to router B. Well, let's go now on to our layer 3 switch and add that bogus network to it. So connect to my layer 3 switch. We'll begin our config with router OSPF 10. So what I want to show you here is that our networks are advertised with that 0000, 255, 255, 255, 255 area 0 command. So let's go on to the router. We're going to go on to interface fast Ethernet 0/4. We're going to say no switch port, and then I'm going to say IP address 10.0.2.1 with a 24-bit mask. I know that was all mixed in there, but if I hit up, you can see the command that I entered there. We'll do no shutdown. And now, remember now, I did not do anything else except add that network. If I go back to router C now, router C has a load balanced network now for network 10.0.2.0. Now, the reason for this is the cost to get from router C to the layer 3 switch is exactly the same as the cost to get from router C to router B. Both those devices have network 10.0.2.0 connected. So right here, we're creating a mess in the network that's very difficult to discover and troubleshoot. I hope I have convinced you to never, ever, ever use that all-encompassing advertise all the networks statement. You always advertise all of your networks individually, regardless of the protocol. You do this because you're the administrator and it is your job to make sure that the routing happens correctly. Do not be lazy here. Do it correctly. Hopefully, I have driven my point home here. Let's wrap up this module and this course so we can move on to additional topics in the CCNA training program.